July 23, 2015. NASA calls a press conference. The room fills with journalists. Something big is coming. The announcement echoes across the world. We have found Earth 2.0, a planet 1,400 light-years away, orbiting a star almost identical to our Sun. They call it Kepler-452b, Earth's older cousin, a world that has already lived through what our planet will experience in the future. It is not just another exoplanet. It is a mirror, a window into what happens when a world like ours grows old, when its star burns hotter, when the balance that sustains life begins to tip. And the terrifying question hanging in the air is this: if Kepler-452b shows us Earth's future, what does that future look like? Because our planet is already on a timer, and the clock is ticking. The sun is dying, not tomorrow, not in a million years, but it is dying, and it is taking us with it. Stars do not stay the same, they evolve. Our sun is 4.6 billion years old, and every 110 million years, it grows 1% brighter. 1% does not sound like much, but over billions of years, that light compounds. The heat intensifies, and the delicate balance that keeps Earth habitable begins to break. Scientists predict that in 1 to 2 billion years, Earth will enter a runaway greenhouse effect. The oceans will evaporate, water vapor will trap heat, and temperatures will soar past anything life can survive. The atmosphere will thicken, the sky will turn toxic, the surface will bake under relentless solar radiation. Earth will become Venus, a dead world wrapped in acid clouds. This is not speculation. This is thermodynamics. This is the inevitable consequence of living next to a star that refuses to stay still. And Kepler-452b has already crossed that threshold. Its star is 1.5 billion years older than ours. It has burned hotter, grown brighter, pushed its planet to the edge. If Earth could survive another billion years, it would look like Kepler-452b, and that realization is both fascinating and horrifying. The Kepler Space Telescope launched in 2009. Its mission was simple: stare at one patch of sky, do not blink, watch 150,000 stars, and wait. It was searching for planets using the transit method. When a planet passes in front of its star, the starlight dims, just a fraction. Kepler measured these winks with astonishing precision, and over 4 years, it detected thousands of exoplanets, worlds of every size, gas giants, super-Earths, frozen rocks, burning stones. But on July 23, 2015, one discovery stood out: Kepler-452b, a planet orbiting a G-type star, just like our Sun. Its orbit takes 385 days. Its star is 6 billion years old. Ours is 4.6 billion. Its distance from its star places it squarely in the habitable zone, the Goldilocks region where liquid water can exist. But the most important detail was this: its star is older, hotter, brighter. Kepler-452b is living in Earth's future. For the first time, we were not just finding another planet. We were looking at a version of ourselves, aged, weathered, standing at the edge of habitability. Scientists estimate Kepler-452b has existed in its star's habitable zone for 6 billion years, 1.5 billion years longer than Earth. If life can arise anywhere, it should have arisen there. If intelligence can evolve, it has had more time to evolve there than here. So the question becomes unavoidable: is anyone home? We found a planet that mirrors our future, a world where Earth could have survived another billion years. But survival does not mean thriving. So what is actually there? What does this older, hotter version of our world look like? And if someone is looking back at us from across 1,400 light-years of space, what would they see? Imagine standing on Kepler-452b. The first thing you would notice is the weight. You would feel twice as heavy as you do on Earth. The planet is 60% larger in diameter than Earth, and its mass is roughly 5 times greater. Gravity pulls harder. Walking would be exhausting. Your bones would strain. Your heart would work overtime. The year lasts 385 days, 20 days longer than ours. The sun in the sky is 20% brighter. Not blindingly so, but noticeably warmer. You would burn faster. Scientists believe Kepler-452b is rocky, like Earth. It likely has tectonic activity, volcanoes, mountains, valleys carved by ancient processes we can only imagine. It may have water, or it may have had water, because the critical question is whether it has already tipped into a runaway greenhouse, whether the oceans have boiled away and left nothing but steam and stone. If it has an atmosphere, it is thick, dense, trapping heat like a blanket wrapped too tight. The surface could be scorching, or it could be temperate. We do not know. What we do know is this: Kepler-452b has been in its star's habitable zone for 6 billion years, longer than Earth has existed. If life started there, it has had more time to evolve than we have. But we see no signs, no radio signals, no megastructures blocking starlight, no chemical markers in its atmosphere that scream biology. Either life never started, or it started and died, or it is there, silent, watching the stars just like we are. And we have been listening. Within days of the announcement, the SETI Institute pointed the Allen telescope array at Kepler-452b. 42 radio dishes in Northern California, all focused on one distant point of light. They scanned 2 billion radio frequencies, listening for patterns, repeating signals, anything that could not be natural, anything that might indicate intelligence. The result was silence. Not empty silence. The universe is never quiet, but the kind of silence that means no one is shouting, no one is broadcasting, no one is trying to be found. SETI expanded the search. 9 billion frequency channels, more sensitive equipment, longer observation times. Still nothing, but they keep listening. Because absence of evidence is not evidence of absence. The problem is distance. Kepler-452b is 1,400 light-years away. If we sent a signal today, it would take 1,400 years to reach them, and another 1,400 years for their reply to reach us. 2,800 years, longer than all of recorded human history. By the time we got an answer, our civilization might not exist. The question we asked might be forgotten. And if they sent us a signal 1,400 years ago, we would only be hearing it now. But 1,400 years ago, Earth was in the Middle Ages. We had no radio telescopes, no way to listen. We are ships passing in the cosmic night, close enough to see, too far to touch. Here's the paradox that haunts astronomers. Kepler-452b has been habitable longer than Earth. 6 billion years in the Goldilocks zone. Stable, warm, potentially wet. Life on Earth started almost immediately, within a few 100 million years of the planet cooling. As soon as conditions allowed, chemistry became biology. If that is universal, if life is inevitable given the right conditions, then Kepler-452b should be teeming with it. 6 billion years is an eternity in evolutionary time. On Earth, it took 3.5 billion years to go from single-celled organisms to complex life, another few 100 million to reach intelligence. Kepler-452b has had nearly twice that time. So either life never started, which would mean life is rarer than we think, harder to ignite than chemistry alone suggests. Maybe Earth is an anomaly, a fluke, or life started and died, wiped out by its own star's increasing brightness, boiled away as the habitable zone shifted outward. Or life is there, but we do not recognize it. It does not use radio. It does not build cities. It does not look up at the stars and wonder. It just exists, silent, content, invisible to our searching eyes. Or the most unsettling possibility, they are there, and they are listening, just like we are, waiting for someone else to make the first move. Because in a universe this vast, this old, this filled with potential worlds, maybe everyone is waiting, everyone is listening, and no one wants to be the first to shout into the dark. Kepler-452b will never be visited, not in our lifetimes, not in our children's lifetimes, not for thousands of generations. It is 26 million years away. At light speed, we will never walk its surface, never test its soil, never know for certain if oceans lap against alien shores, or if everything has already burned away. But we do not need to go there to understand what it represents. It is a mirror, a projection of what Earth will become when our sun grows old and hungry. One day, in 1 billion years, Earth will stand where Kepler-452b stands now, on the edge, struggling against a star that no longer cares about the life it once nurtured. And maybe, somewhere across the galaxy, another civilization will point their telescopes at us. They will see a planet in the habitable zone of a dying star, and they will wonder, was anyone there? Did they survive? Did they leave? Kepler-452b is not just a planet. It is a warning, a reminder, a clock counting down to the moment when Earth must choose, adapt, migrate, or fade into the cosmic silence. And the choice is closer than we think.